Hello and welcome to lesson 20. This is all about triangle congruence, and we're going to prove triangles are congruent using information we know about the three sides. So let's first quickly review. Yesterday we learned about exterior angles, and then the day before we learned about how all the interior angles of a triangle add up to 180 degrees. So if I'm given the information here in this triangle, I see this exterior angle here is going to be equivalent to these two angles on the inside, let's see, added together. So I know that the measure of angle 1 here is 15 degrees because that was given information. And I know that the measure of angle 2 is 2x plus 3. And then the measure of angle 3 is 5x minus 60. And I want to find the measure of angle 2. So I've got to set up an equation. And what I know is that the two interior angles added together are going to equal the exterior angle. So when I'm setting up my algebraic equation, it should look like this. And then I'm just going to do what we've been doing, combine my like terms. I'm going to go ahead and add 60 and then subtract 2x so I can stay in the positive. So that's 78 equals 3x. And then 78 divided by 3x is going to equal 26. Now I want to find the measure of angle 2. So at this point I've got to plug in. And what I'm going to plug in for x is 26. 2 times 26 plus 3 is 55 degrees. So the measure of angle 2 is 55 degrees. Explain in words how you could check your work. Well, I could do 55 plus 15, which is, let's see, 65, 70. And then I could prove that by going ahead and plugging in 26 there, subtracting 60, and seeing if I also get 70. So that's kind of how the explanation should look in your own words.
I need an administrator to...
Sorry about that interruption. At this point, you should try to pause the video at this point, see if you can work these problems on your own, and then come back and check your work. All right, so you should have noticed that this is going to be our pre-image here, that's in purple. And this is our image because of these little prime symbols. That means that after something has happened. And it says determine the transformation. So what I'm going to do is I'm just going to draw a vector line here. And I'm going to just see how many times I moved. And what I can see... What I can see here is that I've got 1, 2, 3, 4 to the right. And I went south, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's down 9. So if I'm drawing, there's several ways I can do it. I know it's a translation. So I can draw 4, comma, negative 9. Or you can do it in vector form, like that. Or you could write it in words. 4 to the right and 9 down. Any of those ways are all saying the same thing. All right, now for this one, I got to look carefully. It looks like I'm starting here on the blue image. I go to red, and then I go back to the kind of maroon color. So first I can notice what happens to my coordinates. From A to A, I see that the Y changes. So the first thing that's going to happen is a reflection across the x-axis. And then the second thing I notice is that this is in the same orientation. All the letters are in the same spot. So I can draw my vector line, and I see that I'm not going up or down, I'm just going back. And I'm going back 5. So translation of negative 5, comma 0. So that would be what occurred in that picture. So that's a quick review. Let's move on to learn something new. So today, like I said, we're going to talk about congruent figures. And so the word congruent should be meaning equal to you at this point. And to label congruent figures, you have to know corresponding angles and corresponding sides. So corresponding sides just simply means they're in relative position to each other. And so if I have this triangle ABC, and the second triangle is RST, I can say for certain that angle A is in the same position as angle R. And so that's why we write angle A is congruent to angle R. And if I want to mark up this picture, I use arcs to mark angles, and I use tick marks to mark side lengths. So I can also see that angle B is in the same position as S. So I can say that angle B is congruent to angle S. Now I don't know that angle B is congruent to angle A. So I'm going to use a double arc here and a double arc here to mark up this picture. And then lastly, I see that C, so I have to use 3 arcs, is congruent to T. So I know those 3 angles are congruent. Now I can also say that a side length AB is going to be congruent to RS. And so I'm going to use tick marks for side lengths. BC, I'm going to use a double tick mark here, is congruent to ST, and then AC is congruent to RT. Now this is how my picture would look if I'm marking up this information, because you know how mathematicians, we're kind of lazy, so we like to use symbols. If I'm marking up this picture to give this information, that's what I see. So order does matter when you're naming congruent figures, and that's important because sometimes these triangles, or whatever shape you're looking at, are going to be turned and in different, they're not going to be exactly the same like they are in this picture. So let's look at another example. In this picture, we want to know what series of transformations can we send triangle ABC to DEF. So this is kind of bringing back Unit 2. So what I notice first is that if I turn this triangle here, and I'm going to keep C where it is, I'm going to turn it about this point. So I'm now going to turn this 90 degrees. So B would now be here, and A would now be here. So now my triangle looks like this. Okay, so that's the first thing. The first thing I did was a 90-degree, I suppose that's clockwise. Okay, now there's a couple options I have. I'm going to go ahead and slide it over. Let's see, I'm going to slide it along this vector here. So now I'm here, here, and here. And so that was a translation. So step 2 is a translation of, let's say I moved over 1, 2, 3, 4. And I didn't go up or down, so B4, 0. And then the last thing I'm going to do is I'm going to reflect it. Now I got to see where I'm reflecting it. This blue line is not quite, it's going to be kind of right there in the middle is my reflection line. So if I come across here, I see that it's right here. So I can see that that's 1, 2, 3, 4. So it's halfway between 3 and 4. So I'm going to reflect across the, that's on the y-axis. So it's y equals 3.5. So those will be my transformations, and I know that these triangles are congruent to each other because none of these transformations change their shape or their size. So let's go ahead and practice. You can pause the video at this moment and see if you can write the corresponding angles and side lengths in the correct places. If you would like a little bit more practice, there's a website you can go to, Math Open Reference. It's just a little thing where you can play around with the triangles, and you can see that if they are congruent triangles, no matter how you change the side lengths or the angles, they'll still be congruent triangles. All right, so pause the video and then come back and check your work. All right, so I'm going to start with angle P, which is in this position here, and I see that it has 1 arc and a tick mark. That's another way. Instead of doing double arcs, you can do an arc with 1 tick mark or an arc with 2 tick marks. That's another way to represent. So the one that's congruent to it is L, angle L. And then I've got Q. Well, Q's over here at the right triangle, and so that's going to be angle M. And then I've got R, and that's going to be congruent to angle N. And then, so now when I'm naming this PQR, I'm going to name it L, M, N, so I know that those angles correspond. So then PQ right here, or you can look up here the picture, PQ is going to be congruent to LM. PR, which is the long side, is going to be congruent to LN, and QR is then going to be congruent to MN. Now, you can look in the picture, but if there is no picture, you can look at the position. So P and Q are the first 2 letters, so it's going to be congruent to the first 2 letters in the other triangle, L and M. Okay, so that's kind of what's practicing down here. Because there's no picture, for example, 3, I know these triangles are congruent, but I want to know where what PC is congruent to. So I look, it's in the first and the last position, and so I'm going to do the first and the last position in the second triangle, and I can say for certain that it's going to be congruent to VK. And the same thing for the second situation, I'm looking for angle E. Well, angle E is in the middle position, so it's going to be congruent to angle F. So that's why it's important to write your corresponding positions in the right order. Okay, we've got a little bit of an exploration here. So you may go ahead and pause the video. There's one thing I want to tell you. I've gone ahead and measured all the sides for you, and I've just estimated. So this one is 2.0, this one is 1.5, and this one's 1.8. And then over here it's the same situation, 2.0, 1.5, and 1.8. I want to know, just by knowing that the side lengths are congruent, can you prove these two triangles are congruent? So you're going to need to use your protractor and measure all of the angles. And if all the angles are the same, go ahead and tell me that MOP and LUV are congruent. Okay, well, I haven't written the angle measures down, but you should have noticed that angle M is in fact congruent to angle L, and that angle O is congruent to angle U, and angle P over here is congruent to angle V. So you can prove that two triangles are congruent just by looking at their side lengths, and that's going to work for every triangle. And what we call this is postulate side, side, side. Basically what that states is if you have two triangles and you know that their sides are congruent, the triangles are also going to be congruent, okay? And this is where I'm introducing proofs to you. So proofs are a way of mathematicians showing that two things are congruent. You've seen them before, but we've never actually done one. So when you're doing a proof, actually, you're going to have to come back to the second video. I'm going to go ahead and stop this one at this time. And there's a second video that you're going to have to go on Canvas to check out.